Hello and welcome to another video from Ellensburg Amplifier Repair and Service. My name's Todd, and today we have a Orion on the bench for repair. 275 slash, I would call it a restoration. Usually when I say repair, it's something I gotta replace transistors and whatnot, but this is going to be more or less a restoration because the amplifier itself is functional, but the capacitors have the typical bulging and leaking associated, unfortunately, which is kind of common to these amplifiers. So today's goal is to replace the capacitors that are bulging on us ever so slightly. Ever so slightly? Well, I wouldn't call it slightly. It is definitely rounded. You can see how the top is rounded up. On the capacitors, they should be flat and also somewhat dipped in just a hair, as I think these may get stamped after the fact, I'm not sure, but usually the vent crosses are somewhat slightly recessed in, and these are bulged out. This usually, I find this issue when the input voltage gets a little excessive for the amplifier, for the capacitors used. Let's see, what brand are these? Let's see if I can pronounce this capacitor brand here. Samhua capacitors. I know nothing about those capacitors. They use Nichicons for the primary rail capacitance, but what are these? It just blows me away sometimes. And I just did a live stream on actually on this particular amp, and I said the same thing. It just blows me away. They'll use Nichicon capacitors for the primary rail capacitance, but they'll use oddball capacitors for the filter, for the 12-volt filter. So I don't know. I'm not an engineer. I repair amplifiers. That's what I do. But yeah, I figured today, since I didn't show it on the live stream, today I'm just going to go through and show you how these things come apart in a way where you're not going to destroy the poor thing. Because these amplifiers, if you do this incorrectly, you're probably going to find yourself replacing output transistors. Maybe not one, maybe not two, maybe all. There is a kind of a procedure for these that you can do to reduce the damage that you could possibly cause on the transistors. This holds true, significantly true, if you have a shorted output transistor, which again this doesn't have. So I really can't show you guys right now what I do to replace transistors on these, because this does not have a shorted output. So, but at the same time, we will go over the tips and tricks of replacing the capacitors. There's a few things to note when working on these, the do's and don'ts, I should say, of servicing these amps. Trying to get these screws out as fast as I can for you guys, so I don't have to do the old fast forward. I don't like to do that. I'm not huge on editing videos. What I'll do is I'll shoot the video, I will run it through my editor. If I see anything I don't like, I just cut it out, and otherwise you guys pretty much get the full version of what I do. I just don't have time to do all the fancy stuff that other YouTube channels do, because at the same time, Every time I upload a video on YouTube, it automatically goes to my website. So if you go to ellensburgamplifier.com, I think it's been a while. I think on the front page there's a section to see the videos that I release for amplifier repair. So I don't tailor just to YouTube. Everything I do gets uploaded to the website, so anyone on the internet can go see how I repair amps, whether you're on YouTube or not. So what I did is I took out all the screws. For the bar. I call these tie down bars. I don't know what you guys call them, but I call them tie downs. They're transistor tie downs. Don't try to pull this tie down off. Leave this alone. Personally, I would just not touch it. Unless, of course, you had shorted transistors. But this thermal pad here, that's underneath the transistors that goes to the heatsink, that's where you want to get up underneath. So if this hasn't been cooked too bad, usually this insulator will come right up off the board. So what I do is I just get my screwdriver, get underneath that pad, and push up on the corner of this bar right here. Get up underneath the pad and push up. And you'll hear the amplifier just pop. What it's doing is it's pulling up the transistors up off that pad. Nice. So this amplifier has been a little hotter than the amplifier that I just did the live stream on. How do I know? The thermal pad insulator is actually adhered to the heatsink, which is from heat, or the glue that they have on the backside of this is still, in a good enough condition where it's still stuck to the heatsink. Sometimes when these get really hot, this will degrade and it'll leave stuff right on the backside of the transistors. But these look absolutely perfect. I have zero concerns about these transistors. And I have zero concerns about the vias. Just double checking my capacitors here and make sure there's nothing too abnormal here. But that's how you pop the board out of these heat sinks. So we're going to be replacing all the 12-volt capacitors and the auxiliary power supply capacitors. And it looks like we do have some corrosion going on here. Of course, it looks like this capacitor, the one that's the worst condition, has leaked and gotten down onto some components and traces, and what happens is this acid that comes out of these capacitors will eat right through the solder mask. So once we pull these capacitors out, I'll do the cleanup on that, and then we'll clean up that corrosion to keep it from spreading, because it looks like it has gotten pretty far down around this rail capacitor here. So let's get those things out of there. And what I'm doing here right now is, while my Hago, my FR301 is heating up, I'm just notating the position of the capacitors, because they are polarized. So you want to make sure that you get your capacitors in the right position, the way they came out. Because capacitors, when you hook them up backwards, they'll get a little hot. Just, sorry guys, there's just someone out front there. Okay, so I digress. And I'll show you how I go about, if you don't take notes on your capacitor layout, I'll show you how you go about knowing what polarity they are before you remove the final capacitor. Yeah, before you remove it. I mean, there are other ways to tell, but the easiest way is to make notes. So let's get these things out of here. These do use some, if I remember right, there is some lead-free solder on these. So I am going to go ahead and add. Oh, do I have the wrong tip? I have the wrong. No, okay. Sorry guys, I just was double checking to make sure I didn't have the wrong tip in. So I don't think I do. Alright, so I'm just going to add some leaded solder. To the capacitors. It'll just make things that much easier to disassemble. Disassemble, desolder, remove. Let's see here, there's two over here that I need to get rid of. Yep. They did a fantastic job at bending the leads of those capacitors. Man, makes it a little hard to pull out, but never fear, we'll get them. Yeah, they did. They bent those leads pretty nice. They bent them nicely, which makes it kind of hard to pull these things apart. Oh, I smell electrolyte. Yes, I do. You can't mistake the smell of capacitor electrolyte. It's nasty stuff. It smells like fish oil. And if I can smell it on the bottom side, that means we do have some electrolyte floating around. So, boy, when they cut the lead to the capacitor, they pretty much put it flush to the board. Makes it real hard to pull back apart. But that's what we do. We just pop these bad boys out of here. Oh, that's interesting. Huh. All right. You're probably going, oh, what's he saying? What's he saying? Well, something interesting on that capacitor. See if I can get this thing out of here. They really bent it good. Yeah, boy, they bent that real good. Let's see what we can do about this problem. Usually I can pull that capacitor. So one side is free, the other side is not, because they bent it over right flush. There we go. I felt something else move over on me. Just a film capacitor. All right. So moving on. As they roll out. All right. Getting somewhere. Oh, the felts. I think I mentioned that on the live stream too, that I always forget the felts. There's little felt rings around the RCAs. Input jacks here that if you don't watch yourself, you could lose. Let's see if I can get this capacitor out of here. All right. There's the capacitors. Oh, interesting. I'm gonna have to show you guys what I found on these. Really odd. These Samhua capacitors, some of these capacitors are actually potted on the bottom. That's strange. I wonder why they're potted. I don't think I've ever seen that before. New. Find something different every day. Well, darn it. Looks like the acid might have gotten the better of this one. Or acid, I don't know if I'd call it acid, electrolyte. The capacitor electrolyte is it's not bad. I've seen worse, but it did get this pretty good. Let me bring you guys right on down in here. Let's see here. You can see where the corrosion got a little crazy. Right here. Right there. You can just see. Is my camera going to autofocus on that? I mean, it may or may not. But yeah, so that's what happens when capacitors leak. They just eat right through it. It does clean up relatively easy. It's just unfortunate, you know, that stuff like this happens. It's a nice gear. It looks like it's looks like the electrolyte has spread. You can almost tell how this amplifier was mounted in the person's vehicle by the way the electrolyte has flowed across the board. And then hopefully not too much has happened to traces. It looks superficial. Is that the word, superficial? Just some surface contamination here, oxidization, but nothing that's telling me that it's eaten through completely through traces. So we're doing good. You can see it does, you know, electrolyte does clean up relatively easy. As long as you're persistent, meticulous, find it all. Usually you can stop the progression of the corrosion that this stuff causes. Yeah, typical capacitor corrosion there. But really not bad at all. Yeah, the corrosion did damage one of the vias here. Not bad at all. Not bad at all. So that damaged via here, so this is the negative side right here of two capacitors. You can see that the top hat of this via is gone. So referring back to my notes here, these two spots are negative. So when we put the new capacitor in, what we're going to do is we're going to tie these two legs together. just to make sure that I have a good path, I guess, a good current path between these two capacitors. Because once you place the capacitor on the board, you have no way of getting to the top trace. You can see right where the corrosion has just damaged this just a little bit here. But that's why we're doing this work today, is to resolve the issue. blue greenish color. Good old corrosion from electrolyte. And I do believe, I mean, I'm not sure if electrolyte's an acid or a base. They do make, I think they make chemicals that you can use to remove electrolyte, but isopropyl alcohol, I mean, is the best thing. And every repair person's got isopropyl alcohol, probably by the gallons on their bench. So I just want to get rid of all the blue. Almost looks like it ate the copper trace at this capacitor right here. Almost looks like it. Not good. I mean, it is ground. Hold on, I'm gonna have to get the old helping eyes out here and see what we got going on with this board. Give me 2 seconds, guys. Yeah, it did a good job of eating that copper up. Yeah, to a point where I think it probably took the via with it. So what we're gonna do is I probably will have no choice but to jump that. Yeah, I don't like doing that, but I'm probably gonna have no choice. Using a pencil. So this via right here needs to go down and connect to here. Man, that focus is just, let me just make sure my focus is not on. It is on auto. All right, well, let's just, as I was saying, this via needs to come around and go to this diode right here. This is a diode, and I think the via going to the top side of the board may be damaged here. I think this via right here is probably gone. But never fear. We know how to resolve stuff like that. And of course, I am using the TDK B41896D capacitors. These are TDK, right? EPCOS, TDK EPCOS. 35 volt, 1000 microfarad capacitors. And if you're wondering the polarity direction of your capacitors, the square, there's a square, if they haven't been pulled apart or ripped off, but the square on these is positive. The circle is negative. Looks like I have some solder I got to get rid of first real quick here. Yeah, if you don't get all that solder out, you're not going to get that capacitor leg through there. So, back in business. And then the auxiliary power supply. I'm going to go from a 25 volt capacitor to a 35 volt capacitor. Let's get that camera back up here. Try to get a little bit more of a wider view, better view. I don't know. I don't know what's good, bad, but hopefully something a little bit easier to look at. So what I'm doing is I'm just placing the capacitors just slightly giving a little bit of a kick to the capacitor legs to keep the capacitors from falling out when I flip it over. I don't bend it over flat to the board. I don't want to create something I complain about. But from here, grab myself some solder. I use the Capacitor 44. I do believe that's what this is. Let me see if I can get you. Oh, I ripped the tag off. This is a Capacitor 44. It's been one of my go-to solders since, what, 2012, 2014, somewhere in there. That's when I started to really use the Capacitor solder. So I just take some solder and I apply the solder to the trace that has the most thermal mass, so the large trace, not to the via that's got just the single top hat to it, because you don't want to apply so much heat that you end up ripping the via apart. And then what I do is I just pull up on the capacitor just for a split second. And you'll feel that capacitor just kind of pop up on you. That is how I go about making sure they're flat to the board. Then I double check them. This one here, not quite so happy with it. There it is. Got to make sure they're flat. And then I solder them in place. Now remember the issue we had with the via, the damaged via, which is going to be these two capacitors here. What I'm going to do is I'm just going to bend it down . Let me get rid of all these other capacitor legs here first. Give me some room to work with. And yes, I did leave one capacitor leg there for a reason. Now what I'm going to do is I am going to try to get this just as low as I can. So I don't have any clearance issues to the heatsink, because I know I have room because of the thermal switch. And that is how we are going to resolve that via problem. I mean, luckily it's on the bottom of the board. I mean, there's really, you don't have many options when it comes to, you know, how you're going to resolve through-hole component via damage. Best thing to do is go to its closest location of where it's supposed to go and get a jumper put there. Or you can hope for the best that you get solder all the way. No. Just to go ahead and connect where it's supposed to go. Don't ever, you know, assume or guess that you have a good continuity connection. To a component, and I'm just going to use a meter real quick to see if this via survived that corrosion or not to this diode that I'd mentioned earlier. And I'm showing it has. So just in case, what I'm going to do is I'm going to make sure that I have enough solder here. And that's it. That will be complete. Of course, get rid of my pencil mark here. Why? Because pencils, graphite. Graphite is conductive. I usually use black Sharpie when to mark up my boards when I'm working on them, but that black Sharpie will become a permanent black Sharpie if you were to use it on this particular style of board. You really don't want that, especially if this is a collector's amplifier. You want to try to keep things just as original as possible. I mean, sure, unfortunately, I got to do things like this, but it's parallel to everything. I mean, it's the best I can do with what I have. And that's my goal, is to do my best with the situation that's given to me. Isn't that with normal life too? I think so. Let's get you a little closer to that board, right? I'm sure you guys don't want to stare at a desk. So those are the capacitors replaced. The corrosion's cleaned up and neutralized with isopropyl alcohol. The customer would be able to see some slight solder mask damage from the electrolyte that is leaked. But overall, it's not in bad condition. Capacitors are straight. I always like to make sure my work is straight. Make sure that my corrosion situation is cleared up as good as possible. Perform my other tasks that I do on Orion boards. What I do is I readjust the RCA jack. I will get right down in here with, oh hey, someone has already soldered this. How nice of them. I'll get right down in here with my fine tweezers and I will bend the RCA tab down into the center, which will grab that RCA pin and just give it more of a positive connection. A lot of these older Orion boards suffer from bad RCA connections. And I just bend them in a little bit. What I'm doing is I'm closing that ring a little bit to just bite that RCA pin a little harder. Clean up the potentiometer. I just lift the sticker just a little bit if I can. They kind of use it as a dust cap is good for them, although these potentiometers are not sealed by any stretch of the imagination. I'll spray some BW100 in there, and then I'll rotate that potentiometer a few times. Just to clean that up. Put the sticker back in place. Check the function of the switches by using the dreaded continuity test of your multimeter. And I just want to verify the contact. These back pins have a capacitive circuit across them, so you got to give it just a second. What I'm doing is I'm just verifying the contact of the switches. Nice. Just like that. I mean, that's kind of the general servicing of an Orion amplifier. I will double check the LEDs to make sure the LEDs are placed where I want them to be. Looks good. The red LED is back just a little bit, so I'm going to pull it forward. Nice. Perfect. And then we just put the amplifier back together. And of course, test it from there. These have already been tested for signal, so the signals were already good. Even with damaged capacitors, of course, they'll still function. It's just their capacitance is probably off if they're not directly shorted. So it's always good just to replace the capacitors if you find them bulged. Don't run it. Otherwise, us repair peoples have to clean up all that electrolyte. So yeah, from here, we just put that info back together, get a full test, and get it back to the customer. So I do thank you guys for watching. That's just my general rundown of an Orion 275SX board. Let me right there for you guys. Again, if you have any questions or comments, please leave them down below. I try to answer you guys the best I can, as quick as I can. And ElmsburgAmplifier.com if you want to get in touch with me directly outside of the channel. And again, guys, please stay safe. Keep your fingers out of the rails. Some of these rail voltages can get extremely high. I say this in every video. Safety is always first. A new tech just does not understand that some of these voltages will give you a bad day. So thanks, guys, for watching. We'll catch you on the next one.